All right, so today we're going to be talking about divisibility rules. So we're going to be checking to see if a number is divisible by 2, 3, 4, 5, 6, 9, and 10. So the first divisibility rule we're going to focus on is when the divisor is 2. If the ones digit is 0, 2, 4, 6, or 8, then the number is divisible by 2. In other words, the number has to be even. So any even number is going to be divisible by 2. For example, we have 784. The ones digit is a 4, it's even, so therefore 784 is divisible by 2. A non-example is 183. The ones digit is a 3, so 3 is not even, it's an odd number, so therefore 183 is not divisible by 2. If the divisor is 3, if the sum of the digits is divisible by 3, in other words, you have to add the digits, and then check to see if the sum is divisible by 3. So for example, 348. If I add 3 plus 4 plus 8, the digits of 348, that gives me 15. Is 15 divisible by 3? Yes. So if the sum of the digits is divisible by 3, then the number is divisible by 3. So 348 is divisible by 3. A non-example is 218. So if you check the sum of the digits, 2 plus 1 plus 8 gives me 11. 11 is not divisible by 3, so therefore 218 is not divisible by 3. 4, if the divisor is 4. If the number formed by the last two digits is divisible by 4, then the number is divisible by 4. So for example, 564. So the last two digits is 64. 64 is divisible by 4, so therefore 564 is divisible by 4. A non-example is 429, so my last two digits is 29. 29 is not divisible by 4, so therefore 429 is not divisible by 4. So to be divisible by 4, the last two numbers, or the last two digits in the number, have to be divisible by 4. To check 5, if the last digit is 0 or 5, then the number is divisible. And I need you to cross out this 0, okay? So the number is divisible by 5. That was a typo. So for example, 1065 ends in 5, so that means it's divisible by 5. A non-example is 3214. This ends in 4, so it does not end in 5, so therefore 3214 is not divisible by 5. So in order for a number to be divisible by 5, the last digit has to be a 0 or a 5. To be divisible by 6, if the number is divisible by 2 and 3, have to be both, then the number is divisible by 6. So for example, 2178. Well, I'm going to check 2. It's even because it ends in 8. But I got to check 3. So to check 3, I've got to add the digits. And the sum of the digits is 18. Is 18 divisible by 3? Yes. So 2 is divisible by 2. And it's divisible by 3. So therefore, it's also divisible by 6. So in order for a number to be divisible by 6, it has to be divisible both by 2 and 3. Another example, a non-example, is 416. Now 416 even, it can be divisible by 2, but I have to check 3 in order for 6 to work. So if I add 4 plus 1 plus 6, I'm going to get 11. 11 is not divisible by 3, so therefore 416 is not divisible by 6. To be divisible by 9, if the sum of the digits is divisible by 9, in other words, I have to add the digits up, then the number is divisible by 9. So for example, 945. So if I add 9 plus 4 plus 5, I'm going to get 18. Is 18 divisible by 9? Yes, it is. So 945 is divisible by 9. A 9 example is 631. Well, if I add 6 plus 3 plus 1, I'm going to get 10. Is 10 divisible by 9? No. So 631 is not divisible by 9. And the last number that we're going to check for divisibility is 10. If the ones digit is a 0, then the number is divisible by 10. So in other words, if it ends in a 0, it's divisible by 10. So 4,280 is got a 0 at the end, so it's divisible by 10. A non-example is 3,209. It ends in a 9. It does not end in a 0, so therefore 3,209 is not divisible by 10. So let's try one. Try some. Circle each divisor that the number is divisible by. Okay? So I'm going to check to see if each number, if 10 is divisible by any of these numbers. So I'm going to check 2. I'm going to go back to my list or my rules. And how is it divisible by 2? Well, let's check. In order to be divisible by 2, it has to end in a 0, a 2, a 4, a 6, or 8. In other words, it's got to be even. Well, 10 is even, so it's divisible by 2. So I'm going to circle it. Let's check if it's divisible by 3. So let's go back to our rules. Our rules state for 3, if the sum of the digits is divisible by 3, then the number is divisible by 3. So let's check the sum of the digit. 1 plus 0 is 1. Is 1 divisible by 3? No. So 3 does not work. Let's check 4. If the number formed by the last two digits is divisible by 4, then the number is divisible by 4. Well, the last two digits of 10 is 1 and 0, which is 10. 10 is not divisible by 4, so therefore 4 does not work. To check for 5, if the last digit is 0 or 5, the last digit is 0, so 5 can go into 10. So 10 is divisible by 5. Again, for 6, if both 2 and 3 need to work, 2 works, but not 3, so 6 does not work. For 9, if the sum of the digits is divisible by 9, then the number is divisible by 9. So again, if I add the digits, 1 plus 0 is 1. 1 is not divisible by 9, so 9 does not work. And the last thing I'm going to check is for 10. In order for to be divisible by 10, it ends in 0. And it does end in 0, so it's divisible by 10. So the numbers that work for 10 are 2, 5, and 10. So what I want you to do on your own is I want you to check for divisibility of these numbers for 93, 4,518, 20,000, and 43. So go ahead and do those on your own and use your divisibility rules.